Hello guys, welcome to the second part of our discussion in corrections in tape. So if you missed the first part of this discussion, I provided the link in the description below. So if you want to watch the first part, just click the link in the description. So we have our first example here. A 50-meter tape of standard length has a weight of 0.05 kilogram per meter with a cross-sectional area of 0.04 square centimeter. It has a modulus of elasticity of 2.1 times 10 raised to the 6 kilogram per square centimeter. The tape is of a standard length under a pull of 5.5 kilogram when supported throughout its length and a temperature of 20 degrees Celsius. This tape was used to measure a distance between A and B and was recorded to be 458.65 meter long. At the time of measurement, the pull applied is 8 kg and the tape supported only at its endpoints, and the temperature observed was 18 degrees Celsius. Assume coefficient of linear expansion of the tape is 0.0000116 meter per degree Celsius. Compute the correction due to applied pull of 8 kg, compute the correction due to the weight of the tape, and compute the true length of the measured line AB due to the combined effect of tension, sag, and temperature. So this is an example of combined corrections. Okay? So we compute first the letter A, which is the correction due to applied pull of 8 kg. So we have the formula for the correction due to pull. CP is equal to PM minus PS times the length over the area times the modulus of elasticity. So we have identified PM here from the given. PM is the measured pull, and from question letter A, the applied pull during the measurement is 8 kg. So we have 8 kg. Then PS here, that is the standard pull. Now, standard pull is when we do not have correction. And according to the problem, the tape is of standard length under a pull of 5.5 kg. So we have our PS here, 5.5 kg. Then our L, okay? So we can actually use the entire length, 458.65, or we can just use 50 meter here, okay? Now, take note, 458.65 meter here is too long for a single tape, correct? So what we're going to do here to measure the entire length from A to B, we need to have breaking tape, okay? Or we divide 458.65 here by 50 meter, okay? Since the maximum possible length lang na pwedeng i-measure ng ating tape is 50 meter. So we can use length 50 meter here, L. A is equal to the cross-sectional area, which is 0.04 square centimeter. And the modulus of elasticity is 2.1 times 10 raised to the 6 kilogram per square centimeter. Okay, so let's use this value. So we have correction due to pull is equal to measured pull here, which is 8 kg, okay, minus the standard pull, which is 5.5 kg. And the unit of this one is in kilogram, times the length. Our length here is 50 meters, over the cross-sectional area, which is 0.04 square centimeter, times the modulus of elasticity, 2.1, times 10 raised to the 6, the unit is in kilogram per square centimeter. So we can actually cancel out square centimeter here and the kilogram, okay, and the kilogram. Then the remaining unit would be in meter. So we have CP here, which is equal to 0.001488 meter. Again, this is not the final answer, since this one is the correction due to pull for every 50 meter length. This is not the total correction for the entire length or from A to B. So in order to compute for the total correction, we need to count how many 50 meters do we have in the entire course or in the entire length, which is from A to B. Now, since we are using a 50-meter tape, we cannot measure entirely from A to B since, again, the measured length is 458.65 and the maximum length that our tape can measure is only 50 meters. Okay, so what we're going to do here is to divide the entire length into a 50-meter distance. Kasi yan lang yung makakaya ng ating tape. In this case, so we have 450 divided by 50. That is, we have 9 times. Okay, we have used full length of our tape 9 times. So we have 9 times of 50-meter tape. And we have excess of 8.65 meters on the end of our measured length. Okay, so therefore our CP or our correction due to pull is only for every 50-meter length, and that is not the measured correction for the entire course A to B. So we have already computed that we have used 50-meter length tape more than 9 times for the entire measurement. Okay, so in order to compute for the total pull correction, we have 0.001488 times compute the number of times that we use 50-meter length. So we have 458.65 divided by 50 meters. This gives us 458.65 divided by 50. So we use 9.178 50-meter length to be exact. So we have the total pull correction here, which is equal to 0.01365 meter. Now, since our correction is very small, we should express our answer to 5 or 6 decimal places. Okay? Now, what if we use 458.65 meter instead of 50 meter distance? So we use CP is equal to 8 minus 5.5 times 458.65 divided by 0.04 times 2.1 times 10 raised to the 6. The answer should be 0.01365 meters. So by using the entire length, which is 458.65 meter as our L, we could arrive directly with the total correction, okay, since we have the same answer. Okay, now take note, our answer is positive. Since we have a positive answer, so therefore our measured length is 0.01365 meter too long. Okay, so ito yung excess ng ating measurement due to pull. Now we have the second question here. Compute the correction due to the weight of the tape. In other words, we are asked to compute for the correction due to sagging. So we have the formula CW is equal to W squared, that's the linear weight squared, times the length of support cube over 24p squared, or we have W, the capital letter W, or the total weight squared times the length over 24p squared, where p here, that is the applied pull. Now we can use either of the two, but we have to look at the given weight in our problem. Now the given weight is 0.05 kilogram per meter, so this one is linear weight, so we should use this formula here. Okay, now we have the given W, which is the linear weight, which is 0.05 kilogram per meter, and the length here, or the L, is the length between supports. Now take note, from the problem, our tape was supported only at its end. Now take note again, the maximum length that our tape could handle is 50 meters. So therefore, we divide 458.65 here by 50 meter length. Okay? So again, we know that we have used the full length of tape 9 times. And we have the remaining 8.65 meter. So we have sag correction for every 50 meter length. Okay, so 50 meter. So all throughout, this is 50 meter. And the remaining or the excess length is 8.65 meters. So at this point here. So we have two lengths here. We have 50 meter and we have the remaining 8.65 meters. Okay? Now we have the applied pull. We have 8 kilograms. So we substitute all the values in the formula. So we have CW is equal to 0.05 squared. Now the unit here is in kilograms squared per meter squared times the length 50 cube. Okay, then the unit is in meter cube over 24 times the applied pull 8 squared. The unit is in kilogram squared. So we can cancel out kilogram squared and meter squared. The remaining would be in meter. So we have this one. Now take note, we have 9 times. Okay, we have 950 meter length. Correct? So we have to multiply this correction by 9. Okay? Then we add the correction or the correction due to sag in the excess 8.65 meter. So we have the same formula, 0.05 squared times, this time we use the length 8.65 cube, correct? Over 24 times 8 squared. So we have only used 8.65 meter length here, 1. So we multiply it by 1. Or pwede nang hindi na siya ilagay. So we have the total correction due to the weight, which is equal to 1.83211 meters. So this is the total correction due to sagging. Okay, so this is our question letter B. Now, if you may ask, bakit instead of 9, bakit hindi natin to gawing 458.65 divided by 50 or 9 point something, okay, 9, more than 9 times. Now, the reason is because naka-cube ang ating length. Okay, so hindi siya pwede gawin ito. Applicable lang to siya if or walang exponent ang ating L. Now, for question letter C, compute the true length of the measured line AB due to the combined effect of tension, sag, and temperature. So we have already computed the correction due to pull or due to tension, correction due to sag. So we do not have yet the correction due to temperature. So the first thing we do here is, of course, to compute the correction due to temperature. So we have the formula of correction due to temperature, which is equal to Ct is equal to the coefficient of thermal expansion times T2. T2 is the observed temperature minus T1, that is a standard temperature, times the length 1, or length, that is the length when we have the standard temperature, or L1 here, it's the standard length. So we have K, the coefficient of thermal expansion, which is 0.0000116 per degree Celsius. Now T2 here, the observed temperature. Now during the measurement, the temperature was 18 degrees Celsius. Okay, we have 18 degrees Celsius. And then we have the standard temperature here, which is equal to 20 degrees Celsius. So we have 20 degrees Celsius. And then the length one, since walang exponent ang L, you can use either 458.65 or the 50 meter tape length. Okay, so we use 50 meter first. So we have correction due to temperature is equal to 0.0000116 per degree Celsius, okay, times T2 is 18 degrees Celsius, minus T1, which is 20 degrees Celsius, times the length 1, which is 50 meters. Okay? So we have CT is equal to negative 0.00116, okay? And the unit is in meter, since we can cancel degrees Celsius and the remaining would be in meter. Now take note, this correction is applied only for every 50 meter length. So we multiply it by 9 times, or we have 458.65 divided by 50. Okay, so we have total temperature correction, which is equal to negative 0.01064 meters. Now take note, para hindi ka na mag-multiply ng 458.65 divided by 50, you can go, or you can use L directly equals to 458.65, just like this one, 0.0000116 times 18 minus 20 times 458.65. The result would be the same, which is negative 0.01064 meters. Okay? Now take note, our answer is negative, so therefore this one is too short. Okay? So our goal here is to compute the true length. Now we know that the true length or the corrected length is equal to measured length plus minus the total correction, or CT. Okay, so we have corrected length is equal to the measured length is 458.65. Okay, now we have plus minus the correction due to pull plus minus the correction due to temperature minus the correction due to the sag or due to the weight. Since we know that we always subtract the correction due to the weight or correction due to sag. Okay? So we have the corrected length is equal to 458.65. Now our CP, correction due to the pull, is 0.01365 too long. Okay? 0.01365. But what would be the sign? Is it positive or negative? Now take note, our keyword here is measured, since we are measuring, tama? From the word measure. So therefore, when we are measuring for too long, we add the correction. Now for too short, we subtract the correction. Now for laying out, for too long, we subtract the correction. For too short, we add the correction. Since 0.01365 here, or the correction due to pull, is too long, and our keyword is measuring, okay, measuring, too long, that is positive, so we use plus here. Now due to temperature, again we have negative 0.01064 meter, and that is in too short. Now take note, we are still measuring distance, so that is negative. So we have minus 0.01064 minus the correction due to the sag, which is 1.83211. So CW is always negative 1.83211, and the unit of this one is in meters. So we have the corrected length here is equal to 456.8209 meters. So this one is the true length between A and B. Okay, or that's the true distance between A and B. Okay, and that's it for corrections in tape. So if you have question, just comment it down and I'll try my best to attend your queries. Thank you guys for listening, and please don't forget to subscribe to my channel and like this video. Thank you guys and have a nice day.